We are now going to continue with the answers to the review problems for Math of Finance, continuing with question number 7. In order to have $5,000 in 2 years, how much would a person have to invest if the money will earn 4 5/10% interest compounded quarterly? Well, since it's compounded quarterly, we know M, the number of interest periods per year, has to be 4. We have to calculate the total number of interest periods, so N is equal to the M, which is the 4, times the T, which is 2. That tells us we have 8 interest periods over the course of the investment. We are now going to use the present value formula of how much do we have to put in principal in order to have the $5,000 in 2 years. So we take the 5,000 times 1 plus the I, which is the 4 5/10, divided by the 4. Exponent button, remember it's negative now because we want a number that is less than the 5,000. So we would have to put in $4,571.95. Question number 8, we get to make a choice. Is it more profitable to receive $5,000 now or $8,400 in 13 years? Let's assume that the money can earn 4% interest compounded quarterly. Well, again, because it's compounded quarterly, we know we're going to get 4 interest payments per year. Since it's invested for 13 years, I want to be able to find out the present value of the $5,000. So again, the N is equal to the M, which is 4, times the T, which is 13. So we get 52 interest payments. Now we want to know what will the $5,000 be worth in 13 years. So we use the future value formula for compound interest. So we have 5,000 times, open parenthesis, 1 plus the I, which is the 4% divided by the 4, close parentheses, exponent button 52. And that tells us we'd have $8,388.84. And taking a look at that particular number, we notice is that this amount is less than the $8,400 we would get in 13 years. So what will we do? We will, let's get this done right, we will wait for 13 years to receive the money. Okay, question number 9. Question number 9 says, calculate the future value of an annuity. Since we want the future value of an annuity, we're going to use the future value formula because we know what the periodic payment will be. So let's read the question. Calculate the future value of an annuity of $200 per month. That is the periodic payment of $200 we're putting in every month for 10 years at 6% interest compounded monthly. And for an ordinary annuity, the compounding and the payment periods are exactly the same. Since it's compounded monthly, we know M is equal to 12. Well, we don't have to calculate anything at this point other than the future value because we're going to go to our formulas. We're going to go to financial and we're going to go to future value. And it tells us future value returns the future value of an investment based on periodic constant payments and a constant interest rate. Well, the interest rate, where it says rate, that's the same as I. So we take our 6% divided by M. The N per is the same as N, and that's equal to 12 times the 10. And the payment, every time we deal with money as a payment or information in our function arguments, we're going to use negative because it always uses the fact that money is a fluid object and it goes in one direction. As everybody knows, it's always going away from us. So we have the $200, and that tells us that at the end of the 10 years, we'll have $32,775.87. All right, question number 10. A saving fund currently has $300,000. it is decided to withdraw money monthly. What are the monthly payments if the account earns 6% interest compounded monthly over a 10-year period? Well, since this is the money we have, this is what we call right now the present value, because that's the money we have. And present value can be withdrawing money that we have now to pay us as in a retirement fund, or it could also be for a loan. But whatever the situation, we're going to use the payment function, which is PMT. So we go to formulas, we go to financial, and we're going to go for our payment function. And what we're going to do again is the interest rate. So we have our 6% divided by 12, because that's the I. The N part is the M times the T. That's 12 times 10, which is 120, excuse me. And the present value, again, we're going to put a negative there, is the $300,000. And that tells us we can collect $3,330.62 every month for 10 years. Question number 11. We want to calculate the payment of an increasing annuity at 4% interest compounded monthly if payments are made every month and the future value after 5 years is $20,000. So we call this a sinking fund problem because we want to have $20,000 after 5 years. Again, we can use the PMT function, and because we just did that, we can go to recently used. But because we want the future value, we're going to go to this box, the future value, and we're going to skip present value because that is what we want to have at the end of 5 years. So again, the interest rate is going to be the 4% divided by 12, since the payments are monthly. The N per is the M, which is the 12, times the 5, which gives us 60 payments. We skip the present value because what we want to have in 5 years is $20,000. So we put that in, and that tells us we would have to deposit $301.66 every single month. Question number 12 is a loan, and a loan is always called present value. A loan of $9,000 is to be repaid with monthly payments for 4 years at 12% interest compounded monthly. Again, we want to be able to calculate the monthly payments. So we know the monthly payments, there are 12 monthly payments per year. Again, we're going to go to our payment function. And again, we're going to fill in our template. Again, the interest rate is going to be the I, which is the 12% divided by the 12. The N per is our M, which is the 12, times T, which is 4, gives us 48 payments. And the PV, which is the loan, again, we have a negative number, is $9,000. And we notice that the answers are in 2 places. And that tells us that if we pay $237 per month, we will pay off the amount of the loan. Question number 13, we want to buy a car with a down payment of $500 and payments of $300 per month. And we want to do this for 3 years. The interest rate is 4 5/10% interest compounded monthly. And we want to know what is the amount of the car that we can purchase. Well, because it's compounded monthly, we know M is 12. So the first thing we want to do is calculate the amount that we can borrow. And again, that is the present value function. So we go to our formulas, we go to financial, and we're going to go down to present value. Again, with the present value, we want to find out the payments. So we know that the interest rate over here is the 4 5/10% divided by 12. We know the N per is the 12 times the 3. And we know that the payments we're going to make, so that's negative, is $300. And what that tells us is that we can borrow $10,085.08, which means the total cost of the car that we can afford, since we're putting down a $500 payment, is going to be equal to the amount that we can borrow, the $10,085.08, plus the amount that we are putting as a down payment, which is $500. And we can buy a car for the sum of $10,585.08. And we will continue the next problems in the next video.